All right, so the next circuit we would be looking at is the final circuit on the rectifiers, which is called as, so this is referred as a bridge rectifier. Again, first we will look at the operation, so how the signal shape still be the same because we are still looking for a full wave circuit. It's a full wave rectifier, so the signal shape is exactly identical. But a full wave rectifier requires how many diodes? A full wave rectifier requires 4 diodes. And this type of configuration, the way these diodes are connected like this, you can see the opposite diodes are facing towards the same direction. Right? So for example, if I take D1, D2, they're facing both downwards, whereas D3, D4, both are facing upwards like in the same direction. This configuration, so when you see like this configuration, like a diamond shape, it's usually referred as bridge configuration. So that's why it's called as a bridge rectifier. There are a lot of application to the bridge, but if the bridge has diodes, then that would be a full wave rectifier. So, and carefully observe that there is no center tap transformer here. It's just a transformer. Correct? There is no center tapped in there. It's just like a normal transformer. So the explanation of this one, so let's take a look at how this signal, again the signal we are looking at is still like this, correct? It is still a full wave. So let's take a look at how this circuit will actually provide. Again, carefully observe that how these diodes are actually conducting. So I'm going to redraw this again in order to talk about the operation. And so the first portion of this circuit is pretty much self-explanatory. It's just the transformer which is used to step down the voltage. But this is not a requirement for bridge. You don't necessarily need to have a transformer. Unlike the previous circuit, remember the center tapped is a must. For example, if you don't have 4 diodes and you have only 2 diodes, then you got to go with a center tapped transformer. But if you have 4 diodes, then transformer is not a requirement to have it in order to build a full wave rectifier. You can do it without the transformer as well, but in a lot of applications, transformer is required to step down the voltage. So all we have here is, so remember that opposite diodes will be, so let me pick, in the same configuration. So this is the given structure of a full wave rectifier. So let's say we're going to say diode 1, diode 2. Again, this whole operation is simply based upon forward bias or reverse bias. So where the resistor will be connected, this is how a resistor is going to be connected. From this point of the bridge to this point of the bridge. This is where the resistor is going to be connected. When you're building this circuit on a breadboard too, you need to be really careful. We will do it in the next class, the lab on the bridge rectifier. But this is how it will operate. So let's take Of course, the input signal is sine wave, right? When the signal passes through transformer, what is the input signal shape? When a signal passes through transformer, what is the signal shape? This is only a transformer. The purpose of transformer is to step down. So it's not going to convert AC to DC. It's not a rectifier. So when you passes through the bridge, this is the bridge. The bridge is this guy right here. That's your rectifier, right? So let's take a look at on how this circuit behaves. So let's say first the input signal comes at positive, right? So that means we are talking about positive signal right there. What happens to D1 if the signal is positive? So the diode D1 would be forward bias. So this is what I will do for ease of explanation. Remember, forward bias allows the current, right? So that means diode acts as a conductor, a simply closed switch. So when we talk about positive cycle, so that signal is coming here positive. The diode D1 will be forward bias. What about D3? So the D3 would be reverse bias, correct? Because this side of the diode is positive, negative, correct? But this one is not from the last two classes.
Take a look at what you just did.
Remember, the diode is,
You're showing D3 with a positive potential. Reverse, look. You're showing them both.
oh, just hold on for a minute. So I'm going to clarify to him. Remember, that's the diode symbol, right? Which side is anode and cathode? So that's exactly what I did right there. That's how I know that this side of the line is a negative. That because the signal I'm talking about is the positive cycle is coming in, but the orientation of D3 is the negative is at the top. Remember, positive to the positive only makes it forward bias. So what, you're saying something? This positive right here on the top, it's the input signal positive right here. That's only when I'm talking about positive cycle, I'm putting positive right here just to indicate that it is positive cycle. That's all. It has nothing to do with the orientation of the diode. The orientation of the diode is still negative is at the top for D3, positive is at the bottom, because that's the cathode and anode. The circuit is not going to be flipped. We are not flipping the. We are talking about, so right here is positive voltage coming in, which makes D1 forward bias, correct? So I'm going to redraw that same configuration right here. So positive signal coming in. D1 is forward bias, so I'm going to put a straight line. But D3 is reverse bias. Reverse bias means it's a open circuit. So what will happen is, so now this current will comes down here, correct? Because this side is a closed circuit. So effectively, what I have here is a load resistor. So this current pretty much comes in, goes through D1, and then to the resistor. So you might wonder what happened to D4. You look at the orientation of D4. D4 is reverse for positive, so the D4 would be reverse bias as well. reverse bias. This is also negative and positive, correct? To the source voltage. Again, opposite diodes are phasing towards same direction. So that means when D3 reverse bias, D4 will be reverse bias, and so on and so forth. So this current at this point, it has to go through the resistor. So it will travel through the resistor, and this resistor is effectively connected to somewhere here. Remember, this is positive current still, correct? The current is still being positive. So when it hits this point, it will go through D2 because D3 is already open circuit. So this current is effectively goes through like that. And at this point where it goes back to your source. So it comes from the transformer. At this point, it goes through D1 to the resistor, back to D2, and back to the transformer. Oh, this is only which current we are talking about? Positive cycle. That's what happens. But in the negative cycle, the whole thing will flip around. That's the purpose of D3 and D4.
Well, what changes it from, like on a negative cycle, why is it going to be
We haven't talked about negative cycle yet. So by the time we finish, then if you have any questions on why I need these diodes, then, so in here, you can look at the diode or the current through the resistor. Again, we are talking about positive cycle, correct? So positive cycle still flows through. So pretty much you will get the positive cycle on the resistor. How many diodes are conducting at any given time? Yes, 2. So take a look at your formula for V peak out. It says minus 1.4 because 0.7 for each diode and the signal passing through 2 diodes. So you had to take away 1.4 from whatever the signal coming in. In this case, the signal coming in from the secondary side of the transformer. So whatever that secondary is, peak value, you take away 1.4. So are we clear? This is only for which cycle? Positive cycle. And you see the signal was, you see the direction on the resistor was going from top to the bottom, correct? It's coming from here and going here. And remember that signal is going through the resistor from top to the bottom, which is the conventional version, right? So let's look at the another perspective. So I'm going to clear some stuff here so that we can see the other way around for this signal. So I can leave like that, probably this side of it. So let's take a look at how we can do that negative half cycle. So when we talk about negative half cycle, what will happen to the signal itself? So in the negative half cycle, the signal coming from here, correct? That's a negative. But remember that we talk about always conventional version. When that is negative, then this side would be positive, correct? So let me, yeah, if this is negative cycle, that means that's negative. This would be positive, right? So that's that. So that's basically negative side of it. This one would be. So again, we are talking about, we're going to go with conventional. So Let's say current leaves positive. It enters like that, right? So the first point it will hit is that one, right? So which one is forward bias, D4 or D2? D4. So it goes that way, but the D2 is, sorry, it's a reverse bias. So that's an open, correct? So the current, so we all agree D4 is forward, correct? Because that's positive. And we are talking about positive, but this case positive is at the bottom. Previously the positive was at the top. So now the current will comes from the transformer, hits that junction, but it has to go through, first of all, to the D4, correct? First of all, it goes to the D4. Now it hits this junction again. What will happen to the D1? D1 will be open as well. So meaning that this side it will be open. So the current has to go through the, so you're going to have a load resistor. So I'm going to draw the load resistor right here. So that current has to go through the load resistor. But where the resistor is connected? Resistor is connected to this point right here, right? Let me take away this. So this resistor is connected to this point right here, right? So here what will happen? Again, this side D2 is already open, but the D3 is forward bias. And this point is already connected to that negative. That's the flow. So coming from the transformer, which is positive side, D4 is forward bias. That's why it has to go through D4. And then D1 is reverse bias. So it has to go through the resistor. Look at the direction of current on the resistor. It is from top to bottom, which is exactly same as before. So that's why the signal orientation will be positive half cycle. Yes.
So also if the negative look like this, then
For what?
how come it's not a negative? Because
You see the current direction? You see the current direction?